Here, we have a dataset represented as individual data points. In batch learning, we process the entire dataset at once. The dataset is grouped into a single large dataset for training the machine. The grouped dataset is now sent to the training machine, where it is processed in one go. As we see here, the entire dataset is moved into the training machine for a one-time processing. This process is computationally intensive but ensures the training machine processes all data in a single step. Once the training process is complete, the training machine outputs a trained model, ready for deployment. Batch learning is efficient for processing large datasets at once. It is particularly suitable for scenarios where the data is static and does not change over time. Additionally, the training process is straightforward and often yields optimized models. However, batch learning has its limitations. It requires significant computational resources and memory to handle the entire dataset in one go. Moreover, it cannot easily adapt to new data, making it unsuitable for dynamic environments where data changes frequently. Batch learning is widely used in projects where large, static datasets are available. For instance, it is ideal for training image recognition models where the entire dataset is collected and processed before deployment. It is also used in building recommendation systems for e-commerce platforms or training self-driving car models on large, pre-collected datasets. Such projects benefit from batch learning due to its ability to utilize the full dataset for optimization. In online learning, data is received and processed in small chunks instead of all at once. Chunk 1 is processed by the training machine, and the model is updated incrementally. Chunk 2 is processed by the training machine, and the model is updated incrementally. Chunk 3 is processed by the training machine, and the model is updated incrementally. After processing all the chunks, the training machine produces an updated model, ready for use. Here are some advantages and disadvantages of online learning. Advantages include handling dynamic data, adapting to new information, and requiring less memory. However, it may be slower, can introduce noise during incremental updates, and requires continuous computation. Online learning is often used in applications such as stock price prediction, real-time recommendation systems, and autonomous vehicle training, where data changes over time and requires frequent updates. Here is a summary table comparing batch learning and online learning. Batch learning processes the entire dataset at once, making it computationally expensive upfront but suitable for static data. On the other hand, online learning processes data incrementally, adapting dynamically to new information and spreading computation over time. Examples of batch learning include deep learning models, while online learning is common in online recommendations and IoT systems.